So, ladies and gentlemen, this is my latest project, and in case you haven't figured it out already, it's a fully functional active exoskeleton, which takes your movements and amplifies them. It also is my latest addition to the Iron suit. This is by far my hardest project ever, but it also feels the most rewarding to have finally finished it. The exoskeleton took me around 6 months to make, with breaks in between of course. And I'm going to share with you everything that I've done, and I've break this build down into 3 parts: the arms, the abdomen and the back. I am also going to tell you about my future plans for the continuation of the Iron suit. The basic idea is pretty simple. Sensors detect your arm movement, the ESP32 processes that information, and the motors amplify the motion. But making all of that work smoothly together was way harder than I expected. One of the biggest challenges that I've dealt with was with the sensors, because I had a ton of noise and delay. There was small errors that made the arm feel unnatural or shaky. The arms. The arms are made from perforated steel mounted on top of an aluminum skeleton. The elbow joint uses bearings for smoother movement, whereas the shoulders only use screws, since the space was limited. To close the arm, we have a few straps, which are easier to put together and tighten, as well as a protective layer that keeps your clothes from getting caught in the mechanism and ripped apart. In earlier iteration, the arm also contained the controls, those being a glove with a few switches to control the motors, but it was way too clunky and uncomfortable to use. So I upgraded the controls to these angle sensors, which detect the angle of the arm at all times, essentially turning the damn DC motors into servos. The sensors detect the movement initiated by the users and turn the motor until a certain angle. Everything above that certain angle, it lets the controllers know that you want to put the arm down. Let me show you as an example. As we can see, the motor stops at a certain point, and when we raise the hand above that, we can see it lets the arm down. Without the exoskeleton, holding heavier weights like this for a long time periods becomes pretty tiring. And thanks to the motors, the load feels significantly lighter. The motors don't just help lift weights, but also help you hold it in place. Outside of the sensors and the motors, it also has a driver, which allows the motors to be controlled safely. It works as a bridge between the 12 volts from the batteries and the motors. And when it gets the signal from the controllers, it activates the motors. More about the electronics when we get to the back. And also, we have a pulley system which doubles the strength of the motor. Furthermore, we have an amp meter and a voltmeter on the left hand, and a power switch and a battery percentage indicator on the right hand. Before moving to the back, I also want to talk a little bit about the abdomen, because I think it's one of the cleverest solutions that I came up with in this build. I knew I had to keep it fairly simple, but also we needed to be able to move. So I've decided to add 2 spring pistons in the front, which transfer the weight to the lower body and later, when I will add, to the legs. They also help keep a straight back, which is essential when lifting larger weights. Outside of the pistons, we have also an actuated motor spine, which can be activated from the buttons on the forearm. This will also help straighten your back and later transfer the weight onto the exo legs. Now for the back. It is made out of the same materials as the arms, an aluminum frame with perforated steel on top. We also have a few straps so that we can keep the suit tight on our body. We also have a removable screen to run diagnostics. This will be later added to the hub of the suit so that we can see it on the mask. Next, we have 3 motors, 2 for the shoulders and 1 for the already mentioned spine. There are also 3 drivers, 1 for each one of them. Right near them, we can see the batteries. And as I said, they are 12 volt and are also connected in parallel, so they can offer as much current as needed to the motors. Along them we have the charging ports, which are easy to access. We also have a cage around them made out of perforated aluminum, so not only it offers protection, but also it offers a little bit of cooling. The batteries are 5600 mAh each, and by my calculations, they can run the suit at maximum power for a minimum of 2 hours. But thanks to the gearbox of the motors, which allow us to lift the weight and lock it in place so that we can keep the weight raised without any extra power. And also the added pulley system helps double the motor's power. We should also be able to run it for hours on end, considering these two. Moving on from the batteries, we have a small transformer which takes the 12 volts and transforms it to a nice 5 volt for the bringing of the operation, the ESP32, and the motor drivers. These transformers also has 4 capacitors to clear any noise from the motors. Right above everything, we have 2 last sensors, which are for the shoulders. Next, the code. It's fairly simple, but pretty long. I'm going to leave it on the screen for a little bit, so you can take a look. I spent way too much time on it, but basically, as I said, it reads every angle of the joint, notices your movements, and amplifies them. There also is a function called debug, which allows you to lower your arms in case something goes wrong and you remain stuck, just like in the movies. At one point, the sensor noise was actually so bad that the arms would sometimes move on their own, so I had to spend a lot of time turning on to the software and filtering the signals. It might not be the cleanest or the best, but that's because I've had to do a ton of things to adjust for the delay and small errors of the sensors. Also, for those curious, here's the diagram of the circuit. And as you can see, there is still a ton of noise on the ground wire, so I had to connect the sensors to a different ground pin on the ESP32. And this is what solved every issue. I haven't had any problems with the noise since then. And so, this was it. The past 6 months of problem solving and bug fixes in one video. As a few more details, the exoskeleton weighs around 6.8 kg or 15 pounds, and each arm can lift 6 kg on its own, which is around 13 pounds. This means that on top of our already lifting weight, you can add 12 kg or 26 pounds. This might not seem like a lot, but considering my budget, and also the fact that it is a modular suit, which means that if I get a larger budget I can add stronger motors, I am pretty okay with it. In the future, I want to start by adding some exo legs. This will be a passive exoskeleton, since some motors that powerful will be pretty expensive. I decided that since it will be my first suit, it will be based on the Mark I. That's because I do not want to make some promises that I cannot deliver. This means that everything that I will add on top of this exoskeleton will be some flamethrowers and some armor. If you enjoyed this video, then please consider giving it a like and a comment, since it boosts it to the YouTube algorithm and helps me reach a lot more people. Also, consider subscribing to see the full suit once it's finished.